www.insightsays.com. A recent research has offered a combination of two dominant methods, stratospheric sulfate aerosol increase and cirrus cloud thinning, to reduce global warming and precipitation rates to pre-industrial levels. Write a note on these geoengineering technologies. 200 words. The Hindu introduction. Stratospheric sulfate aerosol. The ability of stratospheric sulfate aerosols to create the global dimming effect has made them a possible candidate for use in solar radiation management climate engineering projects to limit the effect and impact of climate change due to rising levels of greenhouse gases. Delivery of precursor sulfide gases such as sulfuric acid, hydrogen sulfide H2S or sulfur dioxide SO2 by artillery, aircraft and balloons has been proposed. It presently appears that this proposed method could counter most climatic changes, take effect rapidly, have very low direct implementation costs, and be reversible in its direct climatic effects. One study calculated the impact of injecting sulfate particles, or aerosols, every 1-4 years into the stratosphere in amounts equal to those lofted by the volcanic eruption of Mount Pinatubo in 1991, but did not address the many technical and political challenges involved in potential solar radiation management efforts. If found to be economically, environmentally and technologically viable, such injections could provide a grace period of up to 20 years before major cutbacks in greenhouse gas emissions would be required, the study concludes. It has been suggested that the direct delivery of precursors could be achieved using sulfide gases such as dimethyl sulfide, sulfur dioxide SO2 carbonyl sulfide, or hydrogen sulfide H2S. These compounds would be delivered using artillery aircraft such as the high-flying F-15C or balloons, and result in the formation of compounds with the sulfate anion SO42. According to estimates, 1 kilogram of well-placed sulfur in the stratosphere would roughly offset the warming effect of several 100,000 kilograms of carbon dioxide. Cirrus cloud thinning. Cirrus cloud thinning is a proposed form of climate engineering. Cirrus clouds are high-cold ice bath. Like other clouds, both reflect sunlight and absorb warming infrared radiation. However, they differ from other types of clouds in that, on average, infrared absorption outweighs sunlight reflection, resulting in the net warming effect on the climate. Therefore, thinning or removing these clouds would reduce their heat trapping capacity, resulting in a cooling effect on Earth's climate. This could be a potential tool to reduce anthropogenic global warming. Cirrus cloud thinning is an alternative category of climate engineering, in addition to solar radiation management and greenhouse gas removal. www.insightsanindia.com 35 www.insightsays.com. Basic principles. Typical cirrus clouds may be susceptible to modification to reduce their lifetime and optical thickness, and hence their net positive radiative forcing in contrast to the typical low, warm liquid clouds. Material to seed such modification could be delivered via drones or by aircraft. Scientists believe that cirrus clouds in the high latitude of the troposphere are formed by homogeneous freezing, resulting in large numbers of small ice crystals. If effective ice nuclei were introduced into this environment, the cirrus may instead form by heterogeneous freezing. If the concentration of ice nuclei is seeded such that the resulting cloud particle density is less than that for the natural case, the cloud particles should grow larger due to less water vapor competition and attain higher settling velocities. By seeding with aerosols, ice crystals could grow rapidly and deplete water vapor, suppress nucleation and any growth of ice crystals by homogeneous nucleation. The net effect would be a reduced optical thickness and a reduced cloud lifetime, allowing more infrared radiation to be emitted at the top of the atmosphere, as the ice particles sediment out. Less upper tropospheric water vapor and infrared radiation in the atmosphere would consequently cool the climate. Bismuth triiodide Bi3 has been proposed as the seeding material, as it is effective as ice nuclei for temperatures colder than -10 degrees C, non-toxic and relatively inexpensive compared to e.g. silver iodide. The seeding aerosols would need to be added regularly, as it would sediment out along with the large ice crystal. Recently, Union government announced that only electric vehicles X will be sold in India from 2030. To achieve this target, what needs to be done? Examine 200 words. The Hindu introduction. Recently announced decision that only electric vehicles X will be sold in India from 2030. The current National Electric Mobility Mission Plan (NEMP) is set a sales target of only 5 to 7 million EVs and hybrid electric vehicles annually by 2020. On the other hand, the Indian automobile market, which includes 2, 3, and 4-wheelers, is expected to clock an annual sales figure of around 23 million by 2030. Replacing these with EVs would require a significant push as far as vehicle charging infrastructure and batteries are concerned. www.insightsindia.com 36 www.insightsis.com. Steps needed. The transition would require a battery capacity of about 400 gigawatt-hours each year, equivalent to increasing the current global EV battery production by a factor of 5, just to cater to the Indian EV market. This gigantic demand for batteries is an ideal opportunity for the domestic manufacturing industry and job creation. Manufacturing lithium-ion batteries would require critical minerals such as cobalt, graphite, lithium and phosphate. Among them, lithium is of particular importance. The resource endowment is limited to only 9 countries, and 95% of global lithium production comes from Argentina, Australia, Chile and China. To meet India's demands amid a global surge in electric vehicle demand, the entire mineral supply chain needs to be overhauled and expanded. China and the US, which have ambitious electric mobility targets, are way ahead in the race to secure lithium supplies. In order to avoid a scenario like the one that played during the oil crises of the 1970s and the price shocks of 1980s and 2000s, it is imperative that India secure mineral supplies for its domestic industry by acquisition of overseas assets such as mineral reserves and the associated production. India needs to further diversify the supply risk by including lithium in existing PTAs or establishing new PTAs with other lithium-producing countries. However, the move will only enable and not ensure risk-free mineral supplies to India. There is a need to formulate policies incentivizing domestic public and private mining companies to invest in overseas lithium mining assets. India must focus on creating a vibrant battery research and development ecosystem domestically. Currently, the domestic battery market is largely dominated by lead-acid battery technologies. Research should focus on developing alternative technologies containing minerals with low supply risks and battery recycling techniques to recover associated minerals and materials. Recycling lithium batteries present in the waste stream will significantly reduce the burden in procuring fresh resources. Policies that incentivize domestic manufacturing address the need for virgin resources and recycling of used batteries, while constantly pushing R&D for substitutes and alternatives are vital to secure electric mobility. Q. Examine how science and technology S&T will affect geopolitics. 200 words. Live-ementic introduction. S&T has long been regarded as important for economic growth. In fact, Edwin Mansfield and Joseph Alwyn Schumpeter considered technological change as one of the most important factors, if not the factor. And as we see from the jockeying between the US and China, S&T is also a crucial tool to pursue a geopolitical agenda and build strategic leverage in international affairs. Indeed, S&T is critical for ensuring national security and opening new market opportunities. Ownership of superior technology brings greater power and control. To build capacity, nations rely on several policy levers: patent laws, tax incentives, and grants to labs to spur the public sector, private enterprise and academia. Take the example of middle powers such as Canada and Switzerland. It is their S&T capabilities that help them stay relevant in the international arena. Estonia is another remarkable example of how a country can leverage its digital ecosystem to boost its position in the international arena. Israel, a small country with a complicated past in an unforgiving neighborhood, has been able to consistently punch above its weight because of its technological prowess. For the past 50 years, the US has been the world's superpower. It is no coincidence that the period correlates with America's leadership in S&T. China aspires for global domination and it is playing the long game. Innovation takes center stage and it is seen through geopolitical glasses. China has identified 10 technology areas as part of its new Industry Policy 2025 and aims to become an innovative country. Some have begun to call this a Beijing consensus. www.insightsindia.com 37 www.insightsis.com. At home, As India rediscovers its foreign policy mojo, it must act on similar lines. India's recent efforts to shore up its domestic defense manufacturing industry, develop a regional satellite for South Asia and homegrown GPS, as well as establish 20 world-class universities, are all steps in the right direction. To move forward, India needs to recognize the geopolitical reality of S&T. It needs to identify focus areas, analyze what kind of role it can play and where the state can make tactical investments overseas. More specifically, India needs to build the infrastructure which can generate new technologies.